The following example states that the adjacent picture shows the derivative f prime of x of the function f of x. For each question below, justify your answer. So it's important to note again, we're given the graph of f prime of x. So over what intervals is our function increasing? Well, let's go ahead and take a look real quickly at the rules for this. So our function is increasing when the derivative is greater than 0. So let's look for the intervals where the derivative is greater than 0. So back on our picture here, our derivative is greater than 0. Let's see. Well, I'll notate that area. It's right about in this area up here. And it's this area up here. So that's where the derivative is positive. So that means that that's where it's increasing. So let's see. I've already notated the points for you. So the intervals in this case would be from -6 to, let's say, -4.5. Okay. And the other area is, of course, from 3 to 5.5, just about. Okay. Now, the reasoning, the justification for this is because the derivative is positive. The derivative, again, are the points on this graph. So this is where it's increasing. So over what interval is the function decreasing? Well, again, let's take a look. It seems that it's decreasing in about this area down here because it's negative here, and it's negative in this general area, and again negative in this area. So those are the areas where it's decreasing because the derivative is negative. So let's say that is from negative infinity to about -6. And let's see here, about -4.5 to 3. And then the last interval there is from 5.5 on to infinity. Okay, so that's the last interval there. And again, the justification for this is that the graph that we're looking at is the graph of the derivative, and these are the areas where the derivative is negative. Part C says, at what x values does f of x have a local maximum? Okay, well, let's take a look again at our rules for having a local maximum and then subsequently a local minimum. So we have a local maximum when the derivative switches from positive to negative. And a local minimum occurs when the derivative switches from negative to positive. So we're going to look for those areas on our graph. So local max again goes from positive to negative, and the local minimum goes from negative to positive. So let's point out the local max. In this case, we go from positive to negative at around the point -4.5, so that is a point to notate. And then also we go from positive to negative at 5.5, so that's another local max. Now, at what x values does it have a local minimum? Okay, well, where does it go from negative to positive? In this case, at -6, it goes from negative to positive, as we see right about in this area. So -6. And then the other local minimum, of course, would be in this area down here at 3. So -6 and 3 would be the local minimum. So this should answer our questions for this first example.
Made with Doodlecast Pro.